Hey guys, welcome to CS395. This is the binary exploitation in Linux section. And in this video, Sam and I are just going to be going over what this class is going to be all about and what are some of the things that you're going to be learning in this class.
Yeah, I'm Sam. I'm teaching this class alongside with Nihal, and I'm really excited. We're going to learn some great stuff this semester. So let's get on with it.
So my name, as Sam just said, is Nihal. I am a junior at George Mason University, and I'm in the computer science major. I am heavily involved with Mason Competitive Cyber, and through that club, I've competed through a lot of different competitions and done a lot of different things in the field of cybersecurity. I love to reverse engineer code in my free time, and I love to do this sort of hacking stuff.
Yeah, so I'm also a junior at GMU in the CS program. I'm also in the competitive cyber club, which I recommend you guys all join as well, if you have the time. I also work at the Battelle Memorial Institute, where I do cybersecurity stuff there, and also enjoy doing CTFs in my free time and learning how to hack and stuff. So before we go on with the rest of this PowerPoint, first we're going to walk you guys through the syllabus and just go over the important stuff.
All right, guys, so this is what our syllabus looks like. Our contact information is listed at the top. You can see that Sam and I are listed as the student facilitators. Our faculty advisor is Dr. White, and she is the official professor for this class. But Sam and I are going to be the ones who are guiding you through all of the lectures. So if you have any sort of questions or anything, you can just email us right there. We are your first point of contact for this class. But if you need to contact Dr. White, her email is also listed there as well.
All right, so the exciting course we have for you guys here is everyone should know, first of all, that this is a 1-credit course. So if you are not, if you didn't know that, now you know. It's very important to understand that. So cybersecurity is a very special topic that's not very heavily covered in the GMU CS curriculum. So we are going to teach you guys that all. We have a lot of, we're going to be using readings and assignments and a final project, which we'll talk about later. This is our excellent list of topics that we're going to be going over. You guys will learn how to do all this stuff and what all this means over the next 10 weeks.
So your course outcomes are listed right there. You are going to be learning in this course how to reverse engineer programs legally and responsibly. You are also going to learn how to identify the most common vulnerabilities that you see in C programs. You're going to write scripts in Python that will attack these vulnerabilities and exploit them. And you're also going to learn how you can write safer C programs that avoid these sort of vulnerabilities that are very common in these programs.
So for prerequisites, if you're watching this lecture, then you probably already have a C or better in 367. So I'm just going to ignore that. Required materials. We will be distributing to you guys a Kali Linux virtual machine, which we'll be talking about in more detail later. So you'll need VirtualBox to run that, which is a program that will let you virtualize Linux on whatever computer you already have. So we'll all be working on the same virtual computer, technically. And you will also need a 64-bit computer, which you should have if you have any computer that is younger than 3 decades old, and it should be able to run a virtual machine smoothly.
So for this class, you are going to be given different assignments and readings and also a final project. Each assignment is going to be worth 10 points, and there are going to be 5 assignments. The final project will be worth 50 points, so it's going to be 50% of your total grade.
Yeah, if you guys want to contest any grades, you'll have to submit a request within 1 week of the return date. No grade changes will be considered subsequent to that deadline or after the final project is due. All grades will be final after that.
So you will be given 3 free late passes, and you can use these late passes on any of the 5 assignments, but you cannot use them on the final project. After all your late passes have been used, your assignment grades are going to be reduced 10% for every day that they're late. And after 4 days is the final deadline. So regardless of whether you use late passes or not, you must turn in the assignment 4 days after the deadline has passed.
So me and Nihal both mentioned capture the flags earlier, which are basically just hacking competitions. You can go to CTF Time, which keeps track of all the ongoing capture the flags. And if you choose to participate in one of these and solve a challenge, you can create a write-up for a binary exploitation or reverse engineering problem and send it to us, and we'll look at it and grade it. And you can get at most 5 points extra credit for the class.
Our office hours are listed right here. We are going to be doing our office hours through Blackboard Collaborate. Our office hours go from 10 a.m. to 12 p.m. on Mondays and 1 p.m. to 3 p.m. on Thursdays.
So the honor code is in effect for this class, so don't cheat.
If you have some kind of disability or you need some kind of accommodation, just speak with us ASAP.
Yeah, and will be our 10-week schedule. The first 4 weeks of content should be available to you guys now, and we'll release more of that as time goes on, and we'll talk about the final at a later date. And that looks like everything. Yeah, so now we'll get back to the main presentation. So we're going to go over some important terms that you should know for this class. First off, hacking. All it is just making a system do something that it's not supposed to do. And this means either redirecting program flow to do something or giving us control of a machine. This can be done both legally or illegally, and we will be doing legally only this class. So to that end, black hats are the bad guys in the movies wearing the black hoodies on their laptops. The white hats are the good guys like us who hack for good and for justice. So we talked about CTFs. They're capture the flag competitions for ethical hacking, where you just get flags by hacking programs and turn those flags in for points on, and you get on like a leaderboard or something. That's what our homeworks will be based off of. They'll be, if you've ever done a CTF, then you'll feel right at home with our homeworks.
So when we're talking about binary exploitation is a very specific type of hacking. There are other types of hacking as well, such as web hacking, but we're specifically going to be dealing with binary exploitation. And this involves manipulating an executable file. So typically you're going to be reverse engineering or debugging this program, and you're going to be thinking about the following questions. You're going to be thinking about how user input is being handled by the program, how variables are being modified from the program. If you could modify values that shouldn't be modified, that's going to be something that you could use to maybe build your exploit. And if certain input causes unexpected output or a crash, that could also be information that's used to develop your exploit. So this, as you can imagine, requires a lot of low-level programming knowledge. You need to know things like how to read assembly or how to program in C, or how an operating system works. If you've taken CS397, you should already know all of this stuff. So this should not be new to you. In this class, we are going to be dealing with x86-64 assembly, and we are going to be using Intel syntax. I know in CS367, at least when I took it, it was done in AT&T syntax, but we are going to be using Intel syntax. So just keep that in mind. It's going to be the opposite order for your assembly instructions. It's going to be destination, comma, source. We will also be programming in C and Python as well. Mostly Python, we're going to be creating different exploit scripts in Python so that we could just run that script and it'll execute our exploit.
So why study hacking? One, because it's fun. It also makes you look cool. And we also need to know what the bad guys are thinking as good guys, so we can know how to, protect ourselves from the bad guys. And what better way to catch a hacker, you got to think like a hacker. And that's what we do in this class. There's a high demand for exploit developers in this area, in the United States in general, pretty much. You can make a good tidy sum doing this stuff. And there's a very high demand, so jobs are not too difficult to get if you have the qualifications. So please note that hacking is something that you do not own, is very illegal, very, very illegal, and you should not do that unless you have somebody's permission.
So as I mentioned earlier, the course outcomes here are to be able to reverse engineer programs and develop exploits, identify common vulnerabilities, and write safer C programs.
So here's just an overview of how this course is going to work over the next 10 weeks. You should already have a basic knowledge of assembly in C. We won't be, like Neil said, writing very much in C, but you'll be reading a lot of C in assembly. We already have 4 lectures out right now, and you can just tackle those whenever you want. You'll be given weekly lectures and the homework assignments. So each assignment requires that you exploit a binary and submit a write-up, and I'll show you guys a demonstration of what a write-up should look like in a little bit. You'll be graded based on how well your write-ups are. Even if you can't accomplish, fully exploit the binary, if you write down in your write-up like what you tried and you show us that you're like on the right path and that you're thinking the right things, we'll still probably give you full credit. Write-ups must include screenshots, an explanation of how and why the exploit works, and a step-by-step instruction of how to exploit it. Later on, you'll also be writing scripts for your exploits, like little Python files, and those should also be included in your submission as well, either as a picture or as a file. You will be given extra credit if you compete in a CTF, as we mentioned before on the syllabus. There will be a final project where you'll have to create write-ups for multiple executables. So there'll be plenty of like mini homework assignments. Well, I guess they're not mini, but there'll be it's like you have a bunch of homeworks and you can choose which ones you want to do, and they'll be worth a different amount of points. So all you need to do is do enough of those assignments to where you can get the 50 points needed for the A on the final. And as I said before, the honor code is in effect. Cheating makes you evil.
So in this class, you are going to be given a virtual machine, and you need a 64-bit computer that can handle running this VM. So this VM is a custom Kali Linux virtual machine that we created that contains all of the class materials and programs and tools that we'll be using for the next 10 weeks. The username for the VM is written right there. It's CS395. The password is also written right there. It's CS395 is great, exclamation point. This VM is yours to keep, so you can change the system however you'd like. You can break things, you can change the settings, you can add a new user, you can do whatever you'd like. This is your VM and you can keep it. However, we ask that you do not share the VM with people who are outside of this class, because we might reuse some of the programs inside of the VM in future semesters. Make sure that your VM is set up with VirtualBox before starting the next lecture, because we are just going to start using that VM right away.
Yeah, so here we have the instructions for setting it up, installing it, but I'm going to go ahead and show you guys how to do it live. And we'll do that together right now. All right, so here we are on the Blackboard site for the course. In course content at the very top here will be our virtual machine. So the first thing you're going to need to do is download VirtualBox. So go here, download whatever platform you're on, and then install that. It should just be an executable that'll install it for you. And then once you have that, you can open it up and it'll look like this, except you won't have any VMs here. And to fix that, you will need to click on this link that we have for you. Oops. Ignore that, please. Yeah, so click on that link and that'll be a Google Drive link to the VM. So just download this. As shady as that look, I promise it's good. And then once you have that downloaded, you can just follow the rest of the steps that we have outlined there. So you can just import appliance when you're here. And then wherever you downloaded your VM to is where you should pull it from. I put mine on my desktop, so it'll be called CS395. Double click on that, hit next. And here you can see that it's working. We have a virtual machine to use by students for CS395, and we have some stuff already pre-configured for you. So hit import, and then that'll take a hot second. And this is where all of our files for the class are stored. We already have a couple assignments and a couple demos for you, I believe, on this VM. And so that's where you'll be doing all your work, all your hacking will be done in here. So hopefully this will finish sometime today so I can show you that. Hopefully you guys are familiar with Linux. That's the same thing that Zeus is running on. If you've ever connected to Zeus to do some work for like 262 or 267, it's all running Linux under the hood. And Kali Linux is basically just like a hacking distribution of Linux where it has a bunch of cool hacker tools pre-installed in it. And we'll be using those to show you cool stuff any second now. Guess I'll talk about VirtualBox. So once this is done, you'll want to hit on settings because the default settings for this virtual machine will be very poor. It'll your computer won't put a lot of resources towards it. Yeah, if you hit settings here, and then go to system, I believe. Yep, you can see that it doesn't give it a lot of RAM. So you should just give it as much as you're willing to give it. Anything in the green is pretty much fine. Processing is very important. I just like to give it whatever, like -1 of however many cores you can. But if you want to max it out, go for it. Just anything in the green again is fine. Then hit OK there. There's also display settings. You can give it more VRAM, give it more monitors. And I also recommend going into advanced. Oh, it's already set up as bidirectional. So you can copy and paste things from in and out of your VM, your system, your host OS clipboard will be the same as the virtual machine clipboard. And that's very useful. So now that this is all set up and configured and installed, you can just double click on it. And then it will boot up the VM. And hopefully we will see a login screen after it's done booting. Just hit enter there. And it should give us the opportunity to say CS395 is great. Perfect. This is the cool Kali Linux. Wow, look at how cool it is. Look at how hacky it is. And now, yeah. So the password and username are on the syllabus and on the previous slide. So it's CS395 is the username. And CS395 is great, exclamation point. And that will bring us in to our awesome virtual machine that doesn't fit the screen. Hopefully that's okay. Just go into display here and fix your resolution. You can apply that. Cool, and I actually forgot that's not my resolution. There, beautiful. And now the last thing I'll show you guys is that here you can see that there's a CS395 folder already on the desktop, as well as some tools in Ghidra, which we'll get into in the coming weeks, which you should be excited for. And yeah, you can see we have the course content already split up for you. You can see you'll have your lectures, the slides are here, and some of the demos that we do in the class are stored all in these folders. So for the week 7 and week 9 are not on here. Those you'll have to pull from Blackboard. And if anything changes, if we want to pull any of these or tell you that something is wrong, we will either send you an email and then post an amended version on Blackboard. And that is all I have to say about this VM, I think.
All right, guys, now we are going to be going over what a sample write-up should look like for any sort of assignment that we give you in this class. So if you just go to the assignments folder and click on sample assignment, and then click on the PDF file that's in there, that's going to show you what our sample assignment would look like if we were turning something in. So this is an example that Sam wrote up, which explains how he would exploit a binary that's given to him in an assignment. So he just writes up, the steps that he took in order to exploit this binary and get a shell. You can write in first person. This isn't like an English class where you have to write in third person, or you're not being graded on that. You're being graded on the content of the of your exploit and how well it works and whether it does what we asked you to do. We also want you to include screenshots of your exploit working. So if we could just get like a screenshot of you running the exploit and getting it to work, that would be great.